All right, plot your worksheet from yesterday. Yesterday we started working with the idea of counting. Now we can count people up in this class, 1, 2, 3, 4, 5, and so on. But that's not the counting we're talking about. We're talking about the counting of numbers of ways of being able to do things. And we're using a multiplication principle, sort of like this and this and this. So we're multiplying out. And we learned yesterday if we are counting up number of possibilities of doing things, we use the idea of a factorial and be able to utilize the factorials. You'll see, once again, as we go through this, just like I did with probability, you're going to be dealing with a lot of blanks. I'm going to throw in a lot of blanks here. The factorials, once again, if we look at problem 1/2. We have 11 divided by 15! And we want to be able to simplify this down. As we talked about, there's one way you can list all the numbers out and cancel things out. I don't want a decimal as a solution. Or as you learn to work with these, I take the bigger one, which is the bottom one, or I keep the smaller one the way it is. And the bigger one I expand out, but I stop it at the 11! Because from this point on, this is 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. This is 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All of them are factors, and if they are factors, we can cancel them out. So we can cancel out to give us 1 and 1. So all I'm left to cancel that or multiply is 15 times 14 times 13 times 12. Don't forget about your 1 on top. And then we have 32, 760. Once again, don't forget about your 1 on top there. We go down to the bottom. Okay, number 2. How many ways can a baseball manager arrange a batting order of 9 players if he has 11 players to choose from? Once again, you will see me and you'll see on my solutions I give you, I will put a lot of blanks there. We have 9 people in the batting order. This is position 1, position 2, position 3, position 4, position 5, 6, 7, 8, and 9. So those are all my positions. He has 11 people to choose from. He has 11 people to choose from. So if I'm filling in the first blank, how many people can go in the first blank, Mitchell? 11 of them. In the second place, Andrew Wyckoff, how many can go in the second place? 10. So we have 11, 10. Then how many in the third? Well, we can just keep going down the row here. 9, 8, 7, 6, 5, 4, 3. In the counting principle, when we talk about the counting principle, if I have n ways of doing a certain thing, and then I have n2 ways of doing a second thing, to find the total number of ways of doing these two things, I multiply them together. So we are just multiplying all these values together. It'll give us 19,958,400. If we take a look at problem number 8 on the back. And this will lead right into our notes for today. Front me in the back. A class of 50 students elects a president and a vice president and a secretary and a treasurer. How many different possibilities are there for these elections? So, we have 4 people. So get your 4 blanks down there. If you haven't done it, do it. Okay? And underneath the first blank, I have president. Second blank, I have vice president. Third blank, I have secretary. Fourth blank, I have treasurer. How many people do you have to choose for president? Then, if you're president, you can't also be the vice president, so it has to be somebody different. How many people can be the vice president? Then the secretary, then the treasurer. Find your solution. Allison, how many ways do you have of doing it?
Oh, for the answer?
Yeah.
5,527,200.
50 times 49 times 48 times 47. And these are all multiplied together. Once again, as I've talked about already in this class, the mathematics here is not going to ooh and ah you. We are not learning new mathematics. We're just multiplying 4 numbers together. It's new ideas, new concepts, but we're not really going into complex mathematics. And that will be the same as we go throughout the class. It will be the same. Today is the last section of this chapter. We'll be utilizing the counting principle. What we'll be doing the rest of the week is we'll have worksheets that reviews probability and in-class assignments. Looking at next week, having a review and a quiz on Monday, review Monday, quiz on Tuesday. Today we're going to still utilize the idea of counting principle, but we're going to look at it a different way in regards to what's called combinations and permutations. Combinations and permutations. How many ways can 9 players be, or we got 10 students be arranged in 10 desks, we can do that. But how about 9 baseball players arranged in a batting order? If I was going to calculate how many ways 9 people can be arranged in a batting order, how can we calculate? We have 9 players. We have 9 positions in the batting order. How can we calculate the 9 people in the 9 positions? Trevor, what can we do?
9 factorial. Oh, you mean the line?
You're so boring. 9! So boring. Wake you up here?
Yeah.
All right. I'm a morning person. If you haven't figured that out yet, I'm a morning person. So when you do that, what do you come up with, Trevor?
362,880.
All right. How many ways can 4 students be designated president, vice president, secretary, treasurer? Okay, we just did this problem. Okay, we just did this problem. We're looking at the idea of, oh, I'm sorry, let's go back. You have 4 students. You have 4 students. Sorry, I'm jumping ahead of myself. You have 4 students. How many ways can we arrange them to be president, vice president, secretary, treasurer? We just have 4 students. Oh, and how can we do that? 4 students. We want to arrange them as president, vice president, secretary, treasurer. Well, if I had 9 baseball players in a batting order, how many ways do we have of doing that? Okay, now I'm going to take it down here. I have 4 students designated president, vice president, secretary, treasurer. How many ways can we do that? How would we do it? You want to do it this way? That's fine. What do we have? 4 times 3 times 2 times 1. If you're a little bit more adventuresome here, you can say it's 4! So we have 24 ways of doing this. N is the number of ways n items can be arranged in n ways. Now let's go to the problem that we just sort of finished, but it's going to be a little bit different because now I have 70 students. How many ways can 70 students be designated as president, vice president, secretary, treasurer in a class meeting? If the president is filled first, then everybody has the opportunity for vice president. Then everybody left that has an opportunity for secretary and then treasurer. Go ahead and figure it out. I'm filling up 4 blanks here. I have president, vice president, secretary, and treasurer. And I have 70 students. 70 students in the classroom. How many ways can we arrange those 70 students in that classroom or that class to be president, vice president, secretary, treasurer? And you can only hold 1 class. Check your answer with somebody around you. Lucas, how do we calculate this?
70 times 69 times 68 times 67.
And what do you come up with?
22,005,480.
80. Okay, 22,005,480. Okay, we just did that problem, but we only had 50 students. Well, in the math world, we can call this idea a permutation. A permutation. Oopsie. Having n number of objects and arranging r number of these objects in a specific order. Order is important. This is called a permutation. Having n number of objects and arranging r number of these objects in a specific order. Order is important. This is called a permutation. Having n number of objects and arranging r of those n objects in a specific order. Example, what we just did up there. We had 70 students. We chose 4 of them and arrange them in a specific order. Now, how we denote a permutation. You have two subscripts, one to begin with. You have n with a big P, then an R. So this is n number of objects, and we're choosing 4 of those and arranging them in an order. How we calculate NPR? Maybe. Is n divided by n minus r! Yeah, 2 factorials there. So if I take a look at 10p7, this is my n, this is my r. So we have on top 10! And on the bottom, 10 minus 7! Which is 3! So yesterday we talked about your calculator. With the factorials on your calculator, these will come down to whole numbers because it's the bigger numbers on top. And if you don't have a calculator to use, then you're going to need a calculator here. We can do that and cancel out the 3's! But then you're still multiplying 10 times 9 times 8 times 7 times 6 times 5 times 4. Bless you. Kylie, what did you come up with?
604,800.
What? I'm sorry.
604,800.
Okay, now, if you go to your TI calculator, hit your math button. Okay, you got 4 things along the top up there. Hit your left arrow, which takes you to PRB. So you go math, and then you want to go to, along the top here, PRB. The second option is NPR. You go to that. Nope. Math, NPR. Okay, and it pulls down an answer. Some of your calculators will have little boxes for you to fill in. If you don't have little boxes to fill in, what you're going to have to do first, go ahead and hit the clear button. Hit your clear button above the caret. Type in 10. Type in 10, then go to your math button. Go to your PRB button. Go down to NPR, which is option 2. Hit that. So you got 10 NPR, and then type in 7 and hit enter. And it does the calculations for you. Go ahead and calculate 8P3. Once again, if you can do it either way. And hopefully you can do some mental math here. This is 10 minus 3, which is 5 on the bottom. And this one's a little bit easier to calculate because the numbers are a little bit closer. Once again, you need to find a way it works for you, because you're going to have permutations and combinations. Tyler Ramsey already come up with?
336.
336. All right. Once again, KYC. Know your calculator. Know your calculator. KYC. Is that right? 336. All right. Previous problem up here. You have 70 students. You're picking 4 of those 70 students and arranging them in order. So write a permutation for that. You're picking 4 of the 70 students and arranging them in an order, and order is important. So write first off your permutation because I need to see that. I don't need to see your calculations because a lot of you are going straight to your calculator, which is fine. So in permutation notation, what would this order be up here? What would this be up top? Tyler Ram or Nussbaum? This problem here. I have 70 students. I'm picking 4. How would I write that? Huh? No. N is your first number. The number of possibilities you have. 70. So we have 70. And then P, and then how many are we picking out of that 70? 4. So we have 70 P4. So go ahead and use your calculator, see if we come down to the same solution. And it does a lot of computations for you. A raffle awards 100 bucks, 100 duckies for the first ticket chosen. 50 duckies for the second ticket chosen. 25 for the third ticket chosen. If 50 tickets are sold, 50 tickets are sold. The first one drawn out gets 100. Second one drawn out gets 50. The third one gets drawn out 25. How many ways can the prizes be ordered? Well, is order important here? Yeah, I want to be the first ticket. I get 100 ducks. I don't be the third ticket. I don't want to get chosen. Yeah, I want the first ticket. So I have 50 tickets. 3 of them are chosen. How can I arrange that? Write yourself a permutation. Calculate your answer. Check your answer with somebody around you. How can I write it in this notation? NPR. It's important that you write the notation down. And once again, after you write that notation down, you can go straight to your calculator and find the value. You don't have to show me your computations, but you need to show me it's a permutation. Todd, how can you write that? And once again, at that point, you can just clack it through the calculator. Okay, you don't have to go any further than that. Okay, and what do you come up with? 117,600. We're counting up numbers of ways of doing things. How many ways now, let's think about this, can 70 students be arranged, or how many ways can 70 students, 4 students be chosen to attend the sportsmanship conference? Okay, you're going to a conference. 4 are chosen. 4 are chosen. Now, if we think about what we just did on front, we did 70 P4. We did 70 P4, and we came down to a value, and that value was 22,580,480. But there's a difference here. The reason why each one of those positions can only be held once. There's order that's important. The first person elected just as the president. The second one is the vice president. Third one, secretary. Fourth one, treasurer. In this one, if you're first, second, third, or fourth, it doesn't matter. The first four people are going to be chosen and they're going to go. So in this case, order is not important. Andrew, Nemo, Lucas, Tyler. If they were president, vice president, secretary, treasurer, okay, that's one way of doing that. There's specific order to it. If these two are chosen, or these four are chosen in this order to go to this conference, okay, they're going to go. But if they were chosen in the order Nemo, Andrew, Lucas, Tyler, those four are still going. Lucas, Andrew, Nemo, Tyler, they're still all going. Tyler, Andrew, Nemo, Lucas, they're still all going. Those four people are still all going. Well, each one of those is a separate one up here because if this was president, vice president, secretary, treasurer, that's different than this one, president, vice president, secretary, treasurer. That's different than this one, president, vice president, secretary, treasurer. They're all different. But up here in this situation, all four are still going. I won't call it a reward, but they all get the same award there. Well, I listed four of them. How many ways do we have of arranging those four people? Over there. We have four people. How many arrangements do we have with these four people, Brandon?
4. No, 16.
How'd you get 16?
Hold on, I need to do that. 24.
24, how'd you get it?
4 times 3 times 2 times
4 ways of arranging those 24 people. 24 ways. We have 24 ways. Within this right here is all 24 of those ways. What we are saying in this situation, this is just equal to one way. Because these four people still get to go. No matter how they're arranged, those four people still get to go. So it's still only one group of people. So within this right here is all 24 of these. But then if I took you two, you, and you, we have 24 ways of arranging here. And let's see, you four right here, we have 24 ways of arranging here. You four people, 24 ways of arranging. You four people, 24 ways of arranging. But each one of those ways is equal to 1. So what can we do to simplify this down, the 22 million, how can we simplify this down to create that each one of those 24 ways just equals 1? We could do a mathematical operation. What would it be? What could we do? Yes? Divide by 24. So if we divide this by 24, which was your 4, we come up with ways of arranging this. So if we take 22, 5, 4, 80, divide by 24, what do you come up with, Olivia? 91,000 what? 490? Yes, no, maybe so? Owen, what are you saying? 916,000 what? 895? Is that better? Gotta tell me, you guys have the calculator in your brains, not me. Alright. Let's redo it. Well, what this is called a combination. Having n number of objects and arranging r number of objects is the exact same thing, but no specific order. Order is not important. So it's the exact same thing as a permutation, but now order is not important. Where in permutations, order was important. In combinations, order is not important. So it's the exact same thing as we just did on the front, but now order is not important. The first person chosen gets the same as the third person chosen. The fourth gets the same as the second. And we can write the same notation here as a combination, as a permutation, but now we have a big C. And what I always like to write is I always say this is n objects, I'm choosing 4 of them. When we have no specific order. Well, how do we calculate this? It's n divided by n minus r times r! This is your r right here. So this is permutation right here, but we have to divide by this r. Why? Because that divides out the number of ways we can arrange those r objects. Once again, your calculator. Your calculator will do this for you. We would have 10 divided by 10 minus 7 times 7. Once again, that's the law of permutation or factorials to work with. But your calculator, if you type in your calculator 10, then go to your math button, hit your left arrow to get the PRB. Hit your NCR, then go and hit a 7. It will calculate for you. Go ahead and calculate the next two. And then go back up to the previous problem. Rewrite it. I have 70 people. I'm choosing 4 of them. Order is not important. Rewrite it. See if we come down to the same answer. Tate, what do you get for the first one? 120. That's correct. Second one, what do we get for the second one here? Cole. 56. And then down here, the previous problem where I'm choosing 4 to go to that sportsmanship conference. 4 of them to go to the sportsmanship conference. I have 70 people to choose from. Jordan, how can I rewrite that? How can I rewrite? I'm choosing 4 out of the 70 to go to the conference. How can I rewrite that as a combination? What comes first? What's my n? I have n number of objects. I'm choosing 4 of them. How many objects do I have up there, people? I can hear you. 70. And I'm choosing how many of those? 4. Once again, I need to see that there. Just don't give me a number there. Give me the NCR. And I can clickety-clack it through my calculator. If I clickety-clack it through the calculator, Kayla, what do you come up with? Do we get the same answer as what we got up here?
Yes.
916, 895. A raffle awards $30 for the first ticket chosen, $30 for the second, $30 for the third. 50 tickets or so. Is order important now? Jaden, is order important? No, because the first, second, and third ticket all get $30. Doesn't matter if you're first, second, or third. So order's not important at this point. So go ahead and write yourself a combination. How can I write that in combination form? I have 50 tickets. I'm choosing 3 of them. And then clickety-clack it, calculate it. So Jaden, how do you write this? Now 50, use your C. Now, not just, how would you write it as a combination? Using this notation here. How many are we choosing? How many tickets are being chosen? 3. So we have 50C3. Okay, 50C3. So now, once again, it's up to you whether you want to use your factorials or you want to use your calculator. Alexandria, what do you come up with? 19,600? Yes, no, maybe so? All right. How many ways can a researcher select 5 lab rats from 20 and assign them a different test? Now they're each getting a different test. Is this a combination or a permutation? Mitch, what is it? Permutation, because order is important. So this is 20P5. Now in the second one, the 5 lab rats, they're all getting the same test. It's order important test. Now, so this is going to be a what? Combination. This is going to be 20C5. And once again, If you have to use factorials, that's fine. If you have a TI calculator, it will do a lot of these calculations for you. I suggest if you don't have one, find one. And even if you have a basic TI calculator, if you hit your PRB button on the basic calculator here, it will give you NCR, NPR. So if you, it doesn't have to be a TI 85, 86, whatever. The basic TI calculator will work for you. Okay, it will find your permutations and combinations for you. I strongly suggest you get one or have one at your disposal so you don't have to run through a million factorials here. Okay, keep it simple on yourself. Nemo, what do you have for the first one? Andrew, what do you have for the first one?
1,860,480.
Second one, what do you have for the second one here? Kylie. 2,504?
15,000.
Huh?
15.
15. 2015.
No, 15,504.
Okay, you have homework assignment. I gave you, I'll post solutions. We'll work on this tomorrow. This is the last of our work with respect to probability and counting at this point. Now let's finish up our chapter. Adios. Have a good day.